Hey, I think we're started. All right, so I think it's actually live. Um, so sorry, don't mean to be really. So we'll do this instead of a video, I guess. I just wanted to make sure I could get this to work in Linux, and it's yes, I think it's working. So I had to use Google though, which is really irritating. And I probably should change the frickin' title, but whatever, doesn't matter. People will figure out what it is. It's a video of some kind. Sorry, I'm just going to check that it's working.
I probably should change this.
Yeah, it is. All right. So now we can see the chat also. So that should be good enough. Pretty much. All right. So, yeah. I just want to be able to do this live thing. The Australian guy from a year ago or whatever. So I left a comment. So he must be around somewhere. So maybe some time or other he would like to do a room or something. I'll have to PM him or something if I can find his channel again. you know, um, so that might be good. Then there's the dissonant science guy who doesn't seem as enthusiastic. I mean, I did sort of try to get to do this weekly thing, and he really doesn't seem too interested in the weekly thing. And so maybe it'll be a monthly thing, but we'll see how it goes. So just for that purpose, I want to be able to do these live rooms. In case there's somebody interesting. If there's anybody out there who would like to uh, debate in the live room, send me a PM and I'll hopefully read it. Yeah, or leave a comment. Let me just leave a comment. It's just as good. And then I can contact you about what time you might be available for such a thing, um, and such. Uh, yeah. And so, yeah, it's just so hard to have these conversations because people are really fanatic about it, my opinion. Um, I mean, they can be described as fanatic because they're so, um, like I said, like Day doesn't even have a horse in this race, but he's has such a bias, against me, um, that if it was anybody else making these arguments against the conventional gibberish, he'd probably say, yes, yes, I agree, this is not good enough evidence. Um, and, there's been just so much exaggeration of the depth or the integrity of the experiments that are done in the sense that they are not conclusive in any way. And the radar experiment sort of demonstrates that just because it breaks so many rules of what this quantum mechanical effect is supposed to be. It's supposed to be being caused because you can't know the location of a photon. So when you smash it through a small space, you violate its Heisenberg sensitivities. And there is none of that in two radar transmitters. There's no Heisenberg dilemma that the photon faces, and therefore it must go into quantum mode. Um, that's just to start with. And then there's the argument that in the two slit type experiments where you have this interference, it's clearly okay the single photon scenario. They've done the experiment with the single electron and the single photon, and clearly the single photon is not interfering with other photons. So here you have the radar experiment where apparently that's not the case anymore. Now, individually different photons are interfering with each other, and that wasn't the case in these other experiments. So you have two violations of the rules or premises of their theory that are violated. And then I could go into Heisenberg, that's a third one. I mean, not Heisenberg, I mean Huygens. Um, you have nothing to create the extra, whatever it is, the nothing to initiate, to collapse the wave function, to force the photon to go into quantum mode. So it's another, it's sort of like Huygens is sort of like Heisenberg in the sense the two are rules that all of a sudden cause photons to have to do this this weird thing where they're no longer a particle, they're just a vacuous, wavy thingy in the nowhere, and it's sending out this, it has an extra partner that it creates and all that kind of crap. Well, none of that's in this radar experiment. So it's completely a whole different physics. And here we're supposed to think or believe that, oh, the same rules apply in terms of the outcome. And for the same reasons, because of some interference between photons. When it seems obvious to me that the problem is in trying to receive two different radar signals that are overlapping and that end up out of phase. That's the real solution to the problem. Now, I still don't have an explanation for why the radar gets 4 times weaker when you cover one of the sources. So that one's still an open question, because even in 2-slit math, that 4 times isn't a rule. And it's certainly not part of any extra photons, so to speak. I mean, there's no slit in the middle for extra photons to go through. So how would this 4 times effect be happening? I mean, 4 times just implies a magnification, which you think would be part of how all of these things function. Like I said, why wouldn't they take advantage of that? Why haven't we heard of staged radar, where they deliberately make it interfere so it's 4 times stronger? I never saw that on a ship. I haven't seen 2 radar dishes, shooting the radar out to magnify it 4 times. So, or even sonar or anything like that. And so those are just like glaring problems with these bold assertions. And for Holiday not to admit, yeah, that's really fucked up. That's a really crappy foundation to build an entire model on, that evidence. You got to do a lot better than that. And not to be able to admit that, I mean, it just demonstrates that these are fanatics. They're either fanatics against change, or they're fanatics for their Allah, their little Allah theory of waviness or something. But they obviously have a huge prejudice, a huge bias. And that's a real challenge to have to knock down, because you're not going to get a fair fight. It's definitely going to have to be one of these David against the Goliath things. And that sucks, mostly. Or entirely sucks. I mean, I didn't really expect that, it's one of these things where you just don't expect intelligent people to be this fucking stupid. But they are, it's not even stupid, but yeah, this stupidly biased, this really stupid in their duplicity. I mean, so overtly double standard. You just don't, you would think that smart people would be too smart to obviously impose double standards. It's like just being an obvious bigot or something. Smart people can be racist, but they're usually smart enough to hide it. That's your expectation anyway. But man, lesson learned. So yeah, I just don't know how to make how to evolve the conversation so I can get it to a level it needs to get to, where all of these questions are recognized as dilemmas, in the current theology, and it needs to be cleaned up. That was a little part of the conversation, was what kind of new insight would actually break this nonsense, control of the wave theory. And I'm thinking this idea that all of these interference patterns, they're called interference patterns, might just be duplications of an image. So the two-slit experiment, the little bars are really just images of the slits. And if that's true, if I can demonstrate that somehow, that'll kind of blow up a lot of this crap. And and the only complexity in that is that you have to come up with a mechanism for how photons from the entire slit are somehow replicated all this number of times. Photons going through the same location end up in all these different locations. But part of me says, well, that's not too complicated in the sense that all it requires is the number of interactions you have. If you hit only one thing, then you only move one angle over. You're only one image over. So if this is the image, the next image is here, and the next image is here. It just depends on how many times you hit and get bent. So if if you hit one electron, you end up being at the second bar, from the middle. You hit two electrons, you end up at the third bar. You hit three electrons, you're fourth, and it just goes like that. So it just depends on how thick the number of electrons are. And that sort of fits with the idea as you narrow the slits, you narrow the opportunity for hitting electrons, because there has to be less of them. In a sense, they lose their they end up being surface. They go back to being surface electrons rather than in the gap electrons. That's a whole nother subject, just electrons. Was a lot of different thoughts about how the idea of a free electron is a misnomer, canard. There's no such thing. Electrons really can never be free, because there's always going to be. It's pretty impractical to think, well, you can find locations that maybe you have a balance of charges. There's equal strength between two competing charges. So you could find little tiny locations in the universe where an electron would be satisfied to stay right where you put it. But 99.99% of the spots in the universe you place an electron, it's going to sense a charge difference, and it is going to move, start moving in a direction. Now, there could be places where it's not going to move very fast, but there'll be lots of places where it will move pretty fast, because it's going to sense that charge difference. And so this sort of relates to the idea that the proton has a higher density, charge density, and so there's always extra proton force in the universe, so there's always somewhere to go. And it's only when the electron starts getting close that it starts feeling the repulsion of the little electrons. So from a distance, it feels the attraction of the protons, and up close, it feels the repulsion of the electron. But that's sort of a thing commonly understood about charge, and how it works. And so that's all Maxwell kind of stuff. So anybody who knows that would agree that that phenomenon is sort of a reality in charged circumstances. That in lots of cases, it's the net effect is you can have a net positive attractive force between two things at a mile, but then when you put them 10 feet away from each other, the net force is repulsive, because now they've gotten closer to the little negative bits that were weaker at a distance but are stronger up close, because they're closer when you're up close. Anyway, so the other thing I was thinking about just thinking about the radio waves and how they hit antennas, sort of got me thinking about this idea that, why antennas are long or short wave or long wave radio, the longer wavelength radio signals, that can be up to, a mile long, really long, really low frequency, high, long wavelength radio signals, and the impracticality of any hope of those signals actually hitting the same electron. I mean, you have zero expectation that at that huge amount of time that it takes for the next photon to show up in the frequency, that, whatever electron the other one hit probably isn't going to be in the same place anymore, just because everything's moving and jiggling and there's all kinds of shit going on. And so it really is just about the impact on the electron collective, because all the electrons become a medium. So when electrons are in a group, which it's hard for them not to be in, so let's recognize again, there was an electron here. If I just let one go here, it's probably going to shoot right into me. Let one will go over here, shoot into that flower over. You can't see it, there's a flower there. They'll go over there. Let one go here, go up to the ceiling. They'll go somewhere. They won't just sit there for, no one's bothering me, I'm fine. No, that's not the nature of charge. So they're always going to end up getting stuck in something that will be a puddle of water, something wavy, something that has, that connects them to a group of electrons. So as soon as they go to something and stick on its surface, loosely attracted, with that balance of the repulsion by the other electrons and the attraction of the protons, and they're stuck in that balance, then anything that happens to them ends up happening to the whole group of electrons. Because if that one electron moves, incurs, it gets out of its balance, its comfort zone, I'm okay here because I'm balanced between these different forces. And if it pushes in, it moves a little bit, it's going to force the other electrons to move, or the other protons for that matter to move. And so every impact is recorded by the collective of electrons. And it is somewhere in that collective that decisions will be made about whether something's going to move in and out of an orbital. And it's that movement is where they release the photon of some other kind, like a infrared. So you can convert visible light into infrared light simply by, most surfaces it will hit, and the light will impact the electrons, and most of the time you won't get a photon back. You'll get a warm photon will fly into the material and stay in there, keep moving around in there, keep being batted about in there. So again, but it's still something at frequency, so it still has to be a stream of energy is how this stuff is released in. It's not released in one quanta at a time bits. It's released in more than one quanta at a time bits. Well, that's not entirely true. We can't see or detect stuff that doesn't have a frequency, generally speaking. We can detect gravity, but we can't detect the little bits that are causing it. We can't detect their energy any other way than watching them move collection of electrons and protons. But we don't see the force they emit as a response to that unless it's at a frequency. So yeah, that gets a little bit complicated. But that's sort of the interesting part here, right? It's because so an antenna is not only getting hit by microwaves and radio waves. It's getting hit by light. It's getting hit by X-rays. It's getting hit by gravity. It's getting hit by whatever magnetism might be floating about also. All that stuff's hitting it in any 1/zillionth of a second. And the only stuff we can detect is the stuff we pull out as a recognizable frequency. And some of that's a little difficult to do. Like I said, I mean, you can't see through it. You can't see the infrared radiation, so you need a special device to be able to see what leaks out of it. But you can't see it moving through the thing in any particular way. Anyway, lots of things you can and can't do. All right, so there's a comment in the chat, Mars. I mean, you know, I'm not anywhere near talking about Mars. I'm not even close to Mars. Maybe that's his name. The only issue I have with your theory, which I agree with, by the way, is the idea that quanta are discrete individualized bits. Well, if you don't agree with that part, you really don't agree with anything. That don't add up to anything, bits that don't add up to anything but one totality. I don't even know what that even means. Huh? What? Is the idea that quanta are discrete individualized bits that don't add up to anything to one totality. That doesn't make any sense. Sorry. Can't decipher that. I'm just saying they do add up to something in the sense that there's two forms of the quanta. Those that have gotten stuck together, as I gave examples with like electrons and protons. If they're in relationship in a specific way, you can get them to smash so close together that they become a neutron. You know, anyway, so I think there's the same kind of a system that happens to quanta. Under the right conditions, quanta stick to each other and become electrons and protons. Gravity is the effect of matter acting as one object, which I surmise is the argument for momentum. Monism. Monism? Oh, sorry, you're Mars guy. I'm obviously, if you're Mars, I'm obviously doing Pluto or something. We're not doing the same planet thing. Let's see, somebody with an unpronounceable name. What you think about some man residence, the cause? Shaman residence, the cause. I'm sure I think it's stupid. I'm sure I think it crap. I'm sure I think show me evidence. I'm sure that's what I would say. Show me evidence. Evidence very, very good to me. Good evidence. Good. Bad evidence, bad. All right, that's enough of the comment section. Yes, it's quite, it's very thrilling. Very exciting. Here we go. My college has joint major computer science physics. What do you think about those combinations? Well, I don't think there's any hope of combining computer science and physics. I mean, computer science is programming, in my opinion. The only part that's of any value. The hardware part is just forget about it. Okay, and you're not, unless you're going to design CPUs, that's a whole different kind of science. Okay, electronics. And the only really important part of computer science is the programming, and you don't have to know any physics for that. I mean, it's not physics, realistically. Yeah, I don't think I should necessarily do more Hangouts, frankly, but we'll see. I mean, I think my videos where I draw are very good. Yeah, I think they're better than this kind of loose, what will he talk about? What, it's not as constructed. I don't, But see, what I need is maybe I'll make a whiteboard that I can draw on or something. Got a stiff neck. I'd like to. I have to think of some way to do this. I think I might be able to install another camera, but I'm not sure I can shove both videos into this thing and have it still work. So that's the only problem with that. But technically, it might be a possibility that I could do a screenshot of the other camera while I'm drawing, but I don't know if it's going to be worth the trouble of getting that to work. I had to waste 2 days getting this Linux thing to do this. So, the stupid fucking, the dumbest shit happens in Linux. Sorry, but yeah, I mean, I know it's not Microsoft, so yes, I'm not going to complain, but it's not brilliant either. I mean, the little things that are missing are just kind of amazing. What's your thoughts on the concept of time? Well, time is just, as I keep saying, it's just a function. So it's a function built into matter. So, and if instantaneous ever happened, it would mean there'd be nothing, because everything would happen already and it would already have happened. Everything would have already happened already. So there'd be no room for anything. So obviously, some things has to move slower than instantaneous, or there's no universe. Because if it's instantaneous, then infinity happened already. So yeah, that's all time is. Time is just the speed of the fastest thing. That tells you what the time cycle is, and everything else is just a slower version of that faster thing. Something relative to the fast thing. Oh, fan, yay. You can do that on Twitch. I know, but then I have to go to some dopey place called Twitch. I don't think I can do it. I mean, I did do Tiny Chat, and it really did hurt. I actually felt my penis get shorter. And, to do Twitch, I mean, that's just gonna, I'm on Twitch. Oh, I'm just gonna, it's gonna make me like, I mean, it's not gonna make me like gay. It's gonna make me a faggoty. I don't mind being gay, but I don't want to be a faggot. And you got to be a faggot to be on Twitch. Not sure if they allow physics though. Oh, that's funny. So anyway, but yeah, I can't do twitty things or twitchy things. Nope. No. I'd rather do like something like Fat Ass Book. If they had like Fat Ass Book, I wouldn't mind signing up for that. But Facebook, oh god, too gay. What do you think about the Nobel? I don't see who got them, but I'm sure it's about it's either the gravitational wave guys or the Higgs boson guys or some kind of bullshit. But yeah, it's obviously bullshit. Like I didn't pay any attention. So the only one I'm going to pay attention to is my Nobel Prize. That one's going to matter. These idiots, they haven't given a Nobel Prize to anybody who did anything truly brilliant. Maybe the blue LED guy. But other than that, they've all sucked. Oh, see, it amazes me they give a Nobel Prize to that gravitational wave lie. It's such a pile of shit. It's amazing to give a Nobel Prize to somebody who invented a completely made-up theoretical concept that you can convert matter into bent space. Nobody yet. I haven't seen a single I haven't seen a single defense of that anywhere. I haven't seen anybody say a single word how exactly that's theoretically possible, besides just making it up. I mean, there's absolutely no evidence that matter can be converted into bent space. It violates, frankly, Einstein's E equal mc squared thing. It's just a complete. If Einstein was alive, he'd be like, "Fuck you, cunts!" He'd be like, "How dare you do that?" Fuck you. I didn't invent bed space for you to put Tinkerbell in it. I mean, that's just absolute bullshit, you motherfuckers. I'm taking my bed space home. Fuck you. You can't play in it anymore. You'd be so pissed the fuck off. I mean, just the whole thing is contingent on this fake idea of making this huge preposterous noise. See, they couldn't come up with any real material way to make a a gravitational event that would ever be able to travel light years. There was just no way to do it with common material events. You couldn't create an explosion big enough, so to speak. And so the only way they could do it was to directly channel three solar masses burning for their entire lifetime. So the energy of three suns for their entire lifetime. And they had to channel all that into a millisecond of release in one moment of time to be able to make enough energy to do what they claim happened. And it's just fucking idiotic. Let's see, YouTube stuck at 6. Oh, sorry. I don't know what that. I don't know. Maybe get some Googon or something. So much woo-woo nonsense and no coherency within science. Well, this and no willingness. Like I said, where do I get to go ask the question? Where do I get to get an answer to the question? How do you theoretically defend the idea of releasing all the energy of three suns in 1 millisecond, and yet you didn't create any disturbance in the universe, any noticeable evacuation of everything around that space? I mean, three solar masses in a millisecond is going to move a lot of shit. A lot of shit's going to move pretty fast, pretty far when you release all the energy of three solar masses in a millisecond. How do you reconcile the advanced math that goes along with physics? Well, again, when you just merely scratch at their math, their math that says we predict everything perfectly and we do everything brilliantly, it's a joke, right? I mean, I barely scratched at the two slit math, and all of a sudden I realized, hey, wait a minute, the slits aren't in the math. The math for the two slit experiment is really just the single impediment experiment because the slit width isn't in the math. I mean, the most famous experiment, the two slit experiment, and the slit width isn't in the math. I mean, you know, sorry, no sale. So I can't. What can I say? I mean, I don't do calculus. I'm just. I don't know whether I could do it because it is so fucking strangled in terms of math. Um, but I certainly understand the concept of of adding and multiplying and dividing and what those things do in terms of relationships and representing relationships. And I'm just saying that all we're really talking about is variables that go in, and you can make sense out of those variables. Like Einstein's equations have the same variables you'd expect in a Newton's, right? I mean, the mass of the two bodies, their current position, their current velocity. I mean, these are all just basic numbers, you know. So the sad part is they do the math in Latin, whatever that bullshit is, those silly symbols, and they should have much better acronyms, for their concepts instead of using these fucking symbols. You can make math say whatever you want. Well, that's not entirely true. But you certainly can contrive math to make something be true. You can reverse engineer with math. Math is really good at reverse engineering. You see what the outcome is, you see what it started with, and you create a formula that gets you from start to that end. And that math is really good at. And it's also really good at saying, oh, wait a minute, we get into big trouble when the number gets too big. So we have to have some function in the math that blows the equation up if it tries to go infinity or something. So you can put traps in the math that protect you from, like in the two slit experiment, they don't have a trap. And if I can make the slits infinitely large, and then it's not so predictive, right? So as soon as I make the slit width infinitely large, all of a sudden the product of the experiment isn't going to match the results of the experiment because you're not changing anything that's a variable in the equation. And obviously that's going to get revealed that you didn't change anything, yet you know it will change something. Because obviously more light is obviously going to hit the target. Even if the positions of where the light hits doesn't change, you know if I widen the slits, more light's going to hit. So yes, Greek symbols, whatever. I'm just saying, lambda, delta, theta, it's all very faggoty, and I hate it. Sorry, I don't mean to. Can't do that faggoty thing. I know I got to come up with something else. It's all very peanut butterish. I don't like it. So, yeah, but it's a real problem because people have this perception that math is holy. The holy grail of physics is mathematics, and it really isn't. Yeah, well, depth of the slit, the tunnel effect is a whole different, conceptually, it might reveal what the slits are doing if people did more experiments like that, but obviously that's not really a factor in most cases in what's happening. But it would be really interesting if they had done all these experiments, right? I mean, this is supposed to be the cornerstone of wave theory, and yet you find out they haven't done any kind of experiments. They haven't done any kind of what do you call that? Weights and measures. You know what I mean? They haven't had anybody do a really rigid test. And you see that with math all the time, right? Too. They show you the formulas, but they never show you somebody actually putting real numbers in the formula and actually doing it to more than one or two places out, right? So you never see them really test the theory, the math. They just, give it a little easy test. They barely pedal their little tricycle. They don't give it any stress at all because I think they know it's going to fail. You start going 10 places out, and all of a sudden it starts getting all wacky. But certainly, yes, the physical model is what you're after. I mean, even Feynman said this. I mean, ideally, you want the physical model because then you can just watch the model and get the answer. You can just use the model to test. So if you got the model, you got all you need. And a lot of mathematics is done through measuring devices that are basically a physical model. And that's why they can reliably get results in terms of measuring something, because they're actually a physical yin-yanger, or whatever you want to call it, that's actually going to be able to sense through the actual same physical process that it's measuring. Science is about creating a model of function. It has nothing to do with absolute truth. Well, that's just silly. So I'm sorry. That's just another. Science has everything to do with proving, establishing through evidence. And so if you don't think it's an absolute truth, if you don't think we have absolute proof that the world is round, let's say the Earth is a sphere, then I'd say you're an idiot. There's just no room for saying it hasn't been established beyond reasonable doubt. It's beyond reasonable doubt, and it's double beyond reasonable doubt. So I'd say as soon as you go double beyond reasonable doubt in terms of your stack of evidence, then fuck this bullshit of saying it's not an absolute truth. Of course it is. Well, what it hasn't been. I mean, you're saying, I don't think you can make any blanket statements about all of science. So I just don't think that's right. I mean, Newton was a good scientist. He didn't go beyond. He didn't say much beyond what he could establish through evidence, and so he speculated, and he called it speculation. He didn't say I believe. He said I think it's possible that. So, you know, but I'm not saying that's the truth. He was just really careful about what he said. Here's the evidence points to, and here's what, I'm guessing might be true. And scientists today don't draw those lines at all. I mean, they just come up with a occurs to them. I mean, stuff shit occurs to me every day, and I go, yeah, that sounds right. And then tomorrow it doesn't sound so good. And that's one of the funny things about Einstein, right? Because at the end of his life, he basically said, look, you people think I'm sitting here saying I'm all satisfied and comfortable with what I've accomplished. And he basically said, well, you're wrong. I'm not comfortable. And I think I might have been on the wrong track from I spent my whole life on the wrong track. Something to that effect. A very humble quote. I mean, kind of amazing. He wasn't satisfied. He wasn't comfortable. He didn't like it because it wasn't complete, and it didn't have coherency. He was noticing that. Okay, there's a real problem having, bent space controlling this and quantum mechanics controlling that. That's bullshit. The universe, if he's, Einstein was smart enough to know that, the universe ain't smart enough to have, all these different platforms. Okay, you can't do Windows, Linux, Safari. You can't do all these different varieties. The only belief one should have is to not have beliefs. Well, again, I just that is just too cliche and idiotic. It's just idiotic. Why shouldn't I believe what has been proven? I mean, it's just, I don't know why people do this. They go way too far. Yes, be cautious. And then they say, no, never leave the house. Don't breathe air because it's full of germs. I mean, they just go insanely the wrong direction. Don't drive drunk. And then they turn that into, don't open your eyes because you'll go blind. Well, I don't know what you're saying. I think belief is, I don't know. I mean, I don't know what your definition of the word belief is. Belief is something you hold as a reasonable um, um, description of reality. That's what a belief is. I don't know how you can say it's not a belief if it's proven. That just doesn't make any sense. What do you call the proven ones? Well, that's a silly definition, in my opinion, Mr. Mars. He says belief is something you perceive as true without evidence. No, that's not true at all. You can believe um, um, foolishly, or you can believe wisely. You can believe based on evidence, or you can believe without evidence. It's no distinction. It's like Hoffaday. I mean, it wasn't worth a good laugh when he said naive isn't a pejorative word. So he actually thinks that there's places on Earth right now where one guy is saying to another guy, your understanding is naive, or something like that, and the other guy isn't offended. You think that's actually happened on Earth somewhere, where somebody actually told somebody else they were naive, and the guy who was told he was naive wasn't insulted? Oh, truths is a funny word, but I might say facts are a subset of beliefs. But even that word is, gets fudgy. I mean, all you can go. I mean, once you know the theory, okay, that it's a trial, and that you have to prove something beyond a reasonable doubt. So as long as we have some system that says, well, this is the class of descriptions that are solid, and these are descriptions that aren't evidence-based. They're just kind of, it sounds pretty good, but no evidence. But yeah, once you get into declaring something a fact, oh, that gets so tricky. I mean, you have to be really careful how you word the thing you're going to call a fact. I guess that's all I'd say. I certainly believe there are things that are facts, but clearly, because of all the semantic games people play, you have to be really, really careful how you say how you declare the fact, um, because somebody will play a game with it. I mean, just saying the Earth is round, right? I mean, that can get you into trouble. So you have to say the Earth is a sphere, and then that'll still get you in trouble because it's a little oblong sphere. And then they'll just nitpick you to pieces in terms of trying to just establish that the Earth isn't, a cube. you know. So I guess the safe thing to say is the Earth isn't a cube. That might be safe. Let's see. Facts are a bit misleading because some facts can simultaneously be true and contradict each other. Well, that can't be true either. So, if you have contradictory facts, one of them is broken. One of your facts is broken. I think is more important. Interpretation is just a useless word anyway. No. Again, interpretation is like saying you're just getting back to definitions again. And in my opinion, there's an accurate interpretation and inaccurate interpretation, just as there's a more accurate description and a less accurate description. Yeah, well, computer science is too vague a concept. So I would argue that some programming languages are irritating and some are not so irritating. So that's um, with some platforms, it's like, I mean, I was kind of disappointed about, the learning curve for writing apps, on the Android. And you're like, oh, fuck it. It's just not, I'm gonna have to spend 3 years to become a competent programmer. Because you gotta learn all that Java shit, and you gotta learn this. I mean, just there's so many layers of crap to it. It's more than one programming language it's dependent on, and so that part I would find quite unpleasant. Um, you got to have a passion for that stuff at the time. See, when I learned some programming languages at that time, I had a passion for it. Now I'm too distracted by all this physics stuff, so I would really hate to have to learn a new programming language. I'm not even liking that I have to learn all this crap to get this Linux crap to work right. That's irritating me. You know, I gotta find how I can fix the settings on the camera. It's probably gonna take me a day to figure out how just to change the settings on the camera. Let's see. A third fact can make a situation where on the prior facts reacts different. Well, again, I'm just saying that's a problem with your facts being inexplicit. I'm just saying if you have a correct and accurate facts will not contradict each other. How can I muddle up passion for it? Oh, yeah. Well, you have to not be watching these kind of videos. Yeah, you have to. Well, you have to just think of the future. You know what I mean? So I assume you're a young man, so you have to figure you got a long life to live. And even though you're real horny for other shit right now and kind of excited by other opportunities, you just have to say, okay, it's like I have to go to learning prison. And so I'm just going to have to let this absorb me. I'm going to have to say, yes, I love Java. I love, and you're just going to have to say, I want to know every bit of this. I want to know how to, I want to get deep in its pussy. And, but anyway, it's a head game. You're going to have to somehow fool yourself into thinking you're having a good time. Yeah. It's to be a something other than a sloppy programmer it does require a bit of work. It's the only language I know even half decent. I mean, all of I originally did assembly, which was that was just such fun computer code because it was all just spaghetti code. All you did was go to memory locations. So you fixed everything with a go to. It was just go there. Oh, I don't know what to do there. Go somewhere else. I mean, you just go to all your own functions, and it was just kind of a fun way to program. Just everything just, you know, if then go to, if then go to. Um, can I fuck computer science and physics at the same time, though? Yeah. Well, certainly, I mean, they're not conflicting things in any way. But I'm just saying computer science makes it sound like it has something to do with science. And, does it really? I mean, does computer science have anything to do with science, really? I mean, programming isn't really science, is it? Come on. And the only part of computer science that makes any sense is programming. So I'm just still going to say that. I just don't see any point. Building disk drives or something. I mean, what other part of computer science could be possibly be relevant in terms of the job market or any of that stuff? You know what I mean? I don't think it's going to be any good at all to be a disk drive specialist. Yeah, well, game design that's kind of a specialty. I mean, that's hard to get into because there's so many people that you know want those jobs. Um, so that's a tough market. I had so many great ideas for games, but there's no way to get in. You know, I had like 790 great Tomb Raider levels that I wrote. They never let me write for real. I have them all written in my head. But yeah, I mean, be a good game programmer, you probably have to know more about hardware because it's so hardware demanding. So you really have to know how much you can push the hardware or how to push it without breaking it. Certainly, there's a lot of math to computer science, so you do have to know how to do all that vectory crap. Well, fuck movies. I don't get video game movies, right? That's just lame. You don't get it's not interactive. You know what I mean? You can't jump. You can't do anything. Yes, I have to do a lot of things that I'm not doing. Uh, Discrete math. Yeah, I don't know. I don't know what discrete is exactly, but I guess that's. Well, I'm just saying. See, I mean, I want to do a model of my physics. A computer model, and the model is going to really just be math, right? I mean, the real hard part is just trying to come up with all the formulas that create the activity and under the rules I'm writing, and to get the screen locations to match the math. And yes, infinity is not a good thing. No infinities, please. No. Well, it's probably about time to be completing this test of the emergency broadcast system. This hasn't been an actual broadcast, but if it was an actual broadcast, it would have, it wouldn't have been one of these things with the word live in it and stuff. Let's see, maybe they have an app platform you can SE, then overlay your work. Yeah, there's probably some kind of good, modeling software that's already out there, but it's just so hard to find one that's you can learn, in less time than it takes you to make your own. That's always the catch, right? Because even Firefox has built into it a whole, like a Flash component. And I was going to use that, but I'm saying, shit, it's going to take me a few months just to figure out how to frickin' reprogram this thing, to make little, it makes one bouncing ball, and then you have to, well, okay, if I want to make 500 balls, then I have to do this. It's a lot to figure out how to change it the way I want to change it. So it's like, well, I don't know. It might be, it might take less time to do it, build it myself than is to use somebody else's software that I don't know how to use. But it is, something I got to work on. So much stuff to do. Use YouTube to learn faster. I don't know if that always works. It works sometimes, but it was funny. I was trying to look up to see if I could figure out, I couldn't get the app to work in Firefox, the plugin for the room, and I was all pissed off. So I went on YouTube and searched, and all it came up with was all these Facebook links, Facebook, Facebook video, Facebook. Yeah, it's in a YouTube search. I just thought it was kind of funny that all the videos on YouTube are about how to do video on Facebook. So I thought that was fairly funny. So yes, physics first. And, well, I mean, the model of the physics would be part of the physics, but yes. I can always model it this way. See, this is a proton, this is a proton, this is an electron, and it's almost the same. Yeah, well, social media is such a horrible term. But yeah, Facebook is just such a disgusting. Jeez, YouTube is evil, but I mean, fuck, Facebook is just so bad. Ugh. Anyway, yes, I will. Simulators is a good word. I'll write that one down. Simulator. Simulator. But yes, I don't know. Like I said, I've already tried and I didn't come up with anything brilliant, but I'll try again harder. So anywho, enough said and done. So thanks for whatever, wasting your time with me. Yes. And maybe we can do it again. And sometime in the future. Hey, my screen went all blank. Oh, cool. Anyway, yeah. I really gotta get this. I can't get this lighting in this camera. It's terrible. The more light, the more I just wash out. So it's almost like dark in here. And, it looks like it's bright. You see the screen just came back on. So the screen is part of the enemy here. That's part of my problem. The light from the screen. Huh. So I need to have a darker image on the screen. All right, I have to keep that in mind. So anyway, so until next time and such, happy whatnot and so forth, and bye. Frame rate isn't too good. That's pretty cool though. I like that. Welcome to Linux. It's not Windows. Yes, it sucks, but it's not Windows. Yeah. Okay. Till next time, such.